So this is every speech I'm giving today is really a labor of love. It's stuff that I've been involved with for a long time, and I'm not just interested in tracking airplanes. I'm interested in tracking everything. And I say that because at General Electric, I spent 10 years as CTO of the division. We called it Intelligent Assets, and what we did is track everything. Our main focus was large shipments, trailers, containers, energy generators. The GE had a whole division of generators, and they'd fly a megawatts of generator power. They'd lift it a helicopter and drop it in place, and they could power a whole city. I don't know what they still do in that area, but anyhow, so this was my job, was to track everything, to understand the health of the generator, understand where it is, what kind of hours running, when was the last time it's been maintained, when was the last time anything's been calibrated and checked. And I worked through Katrina. We dropped most of the generators that went into Katrina. General Electric did that. So anyhow, this is tracking is what I do. So this is something I did for fun a long time ago, which was very interesting when you wanted to track an airplane in the 70s, late 60s and early 70s. If you wanted to track an airplane, specifically Air Force One, Air Force Two. I can talk about it now, I guess, right? Can I talk about Air Force One and Air Force Two?
I think the term Air Force things.
But the state of the art of encryption was not very good. So when you were talking about a wireless link in 1970, you're really talking about poor reliability. So when you have the president or vice president on the phone from the airplane link, 707 or 727 in those days, but what you have was a intermittent connection. So inevitably, the pilot would be told to turn off the encryption. So there's a toggle switch in the cockpit. You could turn off voice encryption. Now, again, this was telephone. This wasn't cellular. We didn't have cell phones, right? So you got the vice president needs to talk to somebody, or the president. They would use the aircraft communication, and they would end up turning on or off the encryption if they say, hey, this connection's lousy. What can you do? The pilot would turn encryption off. Now, to a young guy, a hobbyist, with some buddies in Bell Labs, we used to exchange calls in the middle of the night, at least landline. We used to call each other and say, and at the time, this was a Bell Labs in Illinois, and I was living in Chicago, and I was living Chicago is very close to O'Hare, so I was getting all the O'Hare landings, and we knew what they were using, a subcarrier multiplex system, a voice multiplex that would go digital and then turn back to analog if the encryption didn't work, like I said. So we heard some juicy conversations, all I can tell you, especially with Al Gore, but that's another story.
I was going to ask, what administration? What administrations were these?
Well, 70s. Yeah. So Al Gore was the one, I think, the more interesting one when he was on the telephone, Air Force Two, you know.
Well,
and a lot of them, you know, and the other point of communication at that time was not cell, but pagers. Pagers was everywhere, right? So you had pagers. So one of our buddies in this club of ours, monitoring club, right, lived fairly close at Georgetown in DC. And he would be taking all the the pager traffic, you know, and he would take the pager traffic and download it to a server that we could all look at through the old-fashioned FTP. We would FTP to different people's servers, so I could see all the traffic coming in and out of the White House. Okay, that's another story for another time. But and the problem is in the Secrecy Act, in the 1934 Secrecy Act, you really can't talk about it, you know, or you can't make money on it, you know. For the people early on in cellular, when it wasn't encrypted, there were people that were making money, you know, getting the lead on stories. And those people were arrested, and a lot of that was pretty serious felony. Anyhow, so today what I'm going to talk about is tracking. This is really a 4th generation tracking system. So this was something I had put together, and originally the 1st generation was I had not a SDR, but if you wanted to monitor this, I had a swept spectrum receiver where I could see the spectrum and then demodulate the baseband feed, and then I could demodulate ACARS, anything I wanted to do with that. And that took I had some military surplus equipment that did a great job in that. But now fast forward, we have SDRs. So 1st generation of SDRs to the consumer was the dongle, the 8-bit A to D, which isn't great, but it works. It's pretty amazing. And there was great IEEE article, if you read it, about a year ago, on using SDRs. So this started out with SDR, the V3 dongle, and then what I did is I started changing hardware. So this originally, when I discovered there's a Hungarian amateur radio buff that wrote code to take a web browser as a client, and I think I have the architecture of that, and actually have a remote receiver anywhere you want. So this, at one point in time, if you wanted to do it with SDR, you had to buy it from Tektronix, and it started about $9,000. So fortunately, with the hobbyist SDRs, does work. The dongle does work well. So let me go into the presentation where I could talk about. So I've done a couple novel things on this presentation that's really hasn't been done before. So this was an example. Let me go to full screen. Project mode. Okay, there we go. So this just gives you a rough idea on a 767 of all the wireless links you have. So you got antennas. Of course, you got VHF antennas, and you got a whole series of weather radar. You got all kinds of antennas and RF source. And there are people, a cohort of mine got his PhD on analyzing the insecurity around aircraft communication. Well, it's no secret. It can be spoofed. It can be, a lot of it is, in fact, most of it is not encrypted to this day. Yeah. Oh, yeah. And it's not encrypted, and the plane location, it keeps getting better and better with reporting capability. So this gives you some idea of where the antennas are. There's other there's satellite. There's the VHF. There's HF, and then we're going to get into that. And so let me. Okay, so the other surprise we got today, and this is what is unique, is I had this working on a Linux system, and then I decided to port it over to Raspberry Pi. So I had it working on a Raspberry Pi 3B. Raspberry Pi 3B. It's quad core, probably one of the first with quad cores of the Pi family, which is great if you're trying to do some demodulation and decoding of these signals. So then I thought, I just on a lark, I said, well, here's a Raspberry Pi Zero. Does anybody know what a Zero is? The second version, 2W. The W stands for wireless, meaning it has its own Wi-Fi and Bluetooth stack running on it. And it's the size, you can see the size of it. It's really tiny. In fact, I brought a second version of this. So this is what I have in my home right now. So this is in my basement, sitting on some ICOM or Yaesu equipment. But this is a tiny. This is in a metal housing, which is nice. You can buy these now for $15. You can buy them anywhere for $15. So you got a quad core, and I'm thinking, I guess this thing, if it's running in a 3B, well, 3B is the same architecture as the 0 to W. It's the same architecture, only it has, like I say, the Bluetooth and the Wi-Fi stack. And it's the size, it's, look how tiny it is. And I have one that, yeah,
How many cores? This is
four, it's 4 core.
on that,
Yeah, don't believe, for $15.
and this is an ARM.
Yeah, the ARM family, Broadcom architecture, standard Pi architecture, but it's got some other twists too. It's so one of the things you notice right away, hey, it doesn't have enough ports. Well, if you do a power management, if you design anything, you engineer any project, what you don't want is lots of ports. You want only the ports you need. And then in some cases, like the JTAG port, you want to be able to say, go away, float it. So I don't want to use the JTAG port anymore. So here they come out with, and that's not even a port. The micro USB on the right, there's only 2. How am I going to use this damn thing? So the one on the right is just power. So really you have one micro USB as all your I/O, with the exception of your mini HDMI port, your mini video port. That's it. So then after close examination, I'm thinking, okay, they did that to say power. They're not advertising that much, but it's only consumption on this thing is 1 watt max. That's with all 4 cords being used. You're consuming 1 watt. Second of all, now that you have Bluetooth, what the hell do you need all the other, excuse my language, what do you need all these mechanical physical ports when I got Wi-Fi and I've got Bluetooth, right? Because I can start connecting to anything. Most of the keyboards in my house now are Bluetooth. Most of my mice are Bluetooth because to me, that's the way to go, you know? And so then I thought, well, this isn't so bad. But now I got to port this software. I got to move this ISO, burn a micro SD, because that's what runs this, like all the new Pis. You take Rufus or Etcher and you just burn an ISO file from Openwebrx Plus. So there's a website that offers this for download. So this Linux version started many years ago in Hungary when they started porting the idea of a user interface of being a web browser. So here's the cool thing about most modern web browsers. You got JavaScript. So let me see if I have this on here. But I'll get to that. So then there's a whole community in Europe that's been updating this original software, which is SDR. It's SDR Spectrum, meaning it's a fast Fourier library. All the Fourier library components are in there. And it's got the Fourier waterfall. It's got all the functions to have a Spectrum receiver. So what you see as an output, your user input isn't on this at all. So once you get the micro USB in here and it's running, Openwebrx Plus is running on this, SDR Plus. What you're doing now is you make the connection between your Wi-Fi port and your system at home or in your lab or work. So this thing goes into your Wi-Fi and into your connection, and you use something called Nmap to make sure you see where it ends up and how it's defined to the unit. And once you see an Nmap, the second thing you got to do, or I should say, one of the last things you have to do, is then you basically have to put a hole through the firewall. So what you do is you define the 8073 port of this on your firewall. Now you have your system accessible on a browser anywhere in the world, any place, anytime. So I've got this system you're looking at. I'm logged on now, and I'm actually running aircraft decoder software live right now, so which is pretty cool. And this is $15. I got to admit, the case probably cost me $8 by itself. And to set it up, I decided I wasn't going to adventuresome enough to do all the Bluetooth setup because you got to do the basics. For example, the Wi-Fi doesn't turn on this thing until you define your country, because different countries use different Wi-Fi frequencies. So you have to go through the Pi configuration file. And this is a headless configuration, so you don't have a nice GUI. So everything's text line Linux. Yeah.
So the RF conversion to digital happens in that little dongle outside?
Yes, so this little dongle, and again, it's small. So this is known as the common 8-bit, but the improved temperature stability V3, version 3 dongle. So this is kind of ubiquitous. The nice thing, it starts at about 22, 25 megahertz, and it goes up into several 1.7 gigahertz.
And it gives you,
L-band.
you can adjust the bandwidth.
Wait till you see this. You're gonna love this, Lee.
I'm sorry,
You're gonna love
but so
this.
all the RF magic happens there.
Well, right. Your user interface, all the interface to the SDR is done through your web browser. So it's saying, do all your horsepower. There's no GUI on this thing.
Right.
The GUI is your web browser.
And that little box up there, what is it?
So this is the dongle.
Yep.
It's tiny. I mean, I tried to do a macro shot, try to cut out all the junk I had in the background. And this thing's sitting, like I said, on some pretty expensive, nice equipment. But this little baby right here. So this is really the A to D RF part, and this is a simple connector. And this is going into this is the only thing plugged into the USB and the micro. It's the only thing going into that micro USB port.
And what's the bit rate coming out of that?
2.048 megasamples. And it's using I and Q. And I'll go a little bit into the detail.
I'm sorry, I didn't mean to get ahead.
Oh, no. I like questions. It's always good to ask questions,
How much of those, and how are there more than one of them?
So this is what they consider a good dongle. It's not the best. Like I say, I judge these. You know, when I look at this and I say, what's the how well does it handle adjacent signals with an 8-bit A to D? Not very well, because it gives you about 40 dB separation between your interfering signal, because you got an 8-bit. You know, you only have 256 samples. It works well. It's great, except if you have a strong adjacent signal, you'll get some distortion products. I could probably demo the distortion products, but again, the thing is cool is I can unplug this V3 dongle, and you asked how much it costs. It's about $30.
So there are several different variety flavors.
This is a more stable than your garden variety first gen V1s, you know.
So you said 33.
Yeah, it's called V3. They're available. I think you can get them for between 20 and $30.
Where'd you go?
On Amazon. I think I ordered too much on Amazon. The truck's always in front of my house. Between what my wife spends.
Yeah, it says $35 on Amazon. I'm sure you can find it.
Yeah, $35. Now, and there are cheaper ones. I find it works very well. So when you I'm an amateur radio buff, so 10 meters, it worked great. You know, it's no problem down to 10 meters. And then, like I say, the VHF and microwave, you'll see the performance of it. Because this is what's live online, and it's plugged in. Here's what it looks like. So here's the antenna I'm using. That's probably the next logical thing. So this is a discone antenna. It starts at about 20 megahertz on receive. If I want to transmit it, you got to go a little bit higher. It's resonant. It doesn't give you a great SDR 10 meter. But anyhow, up it's great, you know, because it's got its own ground plane. The discone has its own ground plane. You can see from the bottom, and it's up over 30 feet, like a several-story house. But so this is pretty good. It's the damn trees in the way, but other than that, it works pretty well. And we were just talking about this dongle. So this is what it looks like. And the big deal here is this is third generation SDR with a more stable local oscillator. So it doesn't drift as much, and it's slightly improved. It doesn't have a frequency selective front end on this one. But now this can be, the beauty is this thing, you can work with anything. And I'll show you how this, so I have other ones that are roughly $200. It's called AirSpy HF Plus Discovery.
SDR play?
What's that?
SDR play?
Yeah, it'll take the SDR play. So I can plug that in. I have all the whole collection of the things. But this is nice because this is proof of concept because not many people are doing this with the Pi Zero, including the developers. They're telling me it's not going to work, So I'm like, hey, dude, it works. Trust me. Now, what this is online. It's a shareable application that doesn't scale. So if everyone in this room were to log on to this site, they'd probably crash it. Now, for that use, I have many Linux systems, i7s and so forth, and they work great for 20 plus people simultaneously using this. So, but if you look at it, the own developer called me back or shot me an email and said, look, this is in a Telegraph news group, and he said, look, I tested it 3 people simultaneously, it works. And he was shocked. The guy, one of the key developers was like shocked. Anyhow, this is how it works. So you got your INQ being developed here. This is the dongle, and it just shows you how it's picking up the spectrum. And we use what's called so software that's on the Pi Zero then is taking the sampling in through the USB port. In phase and quadrature is taking both of these samples in at a rate of, like I say, 2.048. So I define the configuration file for Openwebrx software, which is this slide here. So, and again, you have the internet data stream. Well, first of all, you've got the INQ from the SDR hardware is your raw in phase and quadrature signal being sampled at 2.048 megasamples. Anyhow, and you have to define that in the software, of course. And then you have a bunch of drivers. So you have different AirPlay is one. There's all kinds of drivers. And then when they don't have one, like they don't have one built in on the AirSpy Discovery HF Plus, but then the developer said, we'll just install the SOAPy. It's called SOAP, which is a common API for SDRs. They call it SOAP or SOAPy. Anyhow, so this is the architecture, what it looks like. So this was originally written in all Python on a Linux system and imported to the Raspberry Pi. And like I said, I was testing on the lowest. This is kind of low and you can't go below this, but it worked quite well for up to 3 people. And this is, let me just jump to one of the most advanced wireless navigation system now for aircraft is the ADSB. ADSB is one of, anybody familiar with that? A couple of years.
It's the pilot's best friend.
You're a pilot, yeah.
Yeah, it's basically, you can sit there, thanks to this, planes report their position and altitude and all that. And so now with a cheap Apple tablet and a receiver, you can sit there and have a picture of all the air traffic around you that's better than what they have what they had in air traffic control 20 years ago. It's just shocking. Oh yeah, everything. And I believe you get tail number too, which is really funny. And you can sit there and watch stuff and then there's magic software to let you know when things are potential hazards to you.
What distance was this along? Like, what's the?
It's 120, roughly 125 mile maximum radius. Because remember, these airplanes are your wireless. One of your wireless sources, besides the ATC or control tower, is and I see I'm maybe 15 minutes from here in Hamilton Square, and I get. Well, you're going to see in real time how many planes you can pick up because I get all the planes coming into Philly, LaGuardia, Trenton, Newark. I mean, this is like, anyhow, this is the original ACARS. So here's what's cool about this software. This is called Openwebrx Plus. So this is the Plus edition.
ACARS is here. Okay, tell them what that is. I'm sorry, I don't mean to do this, but like,
Go ahead.
this is mysterious. Well, I don't know a lot about it, but commercial planes have an in-house communication network. It's a little thing on their dash. They submit flight plans, get weather through it.
Right.
Also support company stuff related to that particular flight. I don't know much beyond that, other than the fact that any big commercial jet has this little panel that pilots conduct a lot of their business through. I didn't know. So you can pick that up?
Right. So ACARS is version 1. So this has been around for a long time. And it's an acronym for aircraft communications. This is a good example. So as Lee was saying, you get text messages. Sometimes it's encrypted. Sometimes it's basis telemetry. So this is telemetry talking about temperature thing. But look at this. The pilot was busy with the console because the pilot is typed up a message here in English. So he's got a morning. What's an LBIK leak? I'm not that familiar with it.
That's a TLA. I'm not familiar with.
Okay, so yeah, so digitally, the pilot has got a console. The pilot can just type in messages. And when I was putting this presentation together, I happened to be looking at not ACARS, but there's 2 versions after this, right? So there's a newer version, but this is the original one. It's 2 tones, so there's tones that are modulating in an audio channel, which then the SDR looks at and converts into say 1s and 0s, and then it interprets it. But what you see in some of the text messages, one of them almost gave me a heart attack. You can watch this thing. It was in the middle of the night. I tend to work pretty late. I'm looking in one eye. I got this thing. I'm looking at the text messages flying by, and the guy's talking about his engine failing. And the one thing as a pilot, what do you got to do? You keep cool, There's nothing emotional in these messages. It just said, "Oh, my left engine has failed," and blah blah blah. Just thought I'd let you know. Got one sentence. So this can be interesting sometimes. Now notice a couple things. So 2 things I want to point you to. So if you look at the right, this is the original ACARS on 131.125 megahertz. Okay, so that's a standard US, one of the standard frequencies for ACARS. Now, if you look up at the top of the screen, you've got a little window that shows a symbol of an icon of a bandwidth adjustment. So that's pointing to one of the ACARS frequencies. So that's what you're reading here. So you're taking a sample, a 200 kilohertz sample, 200 hertz sample of that around that frequency. So in that bandwidth window. So if there's any ACARS signals, like you see the bursts. So there's bursts coming in, and then the bursts are read by the ACARS decoder. Now, here's the cool thing about that's in this software. This is what's amazing. This is what I like about this.
Multiple channels on ACARS?
Yeah. So you got all those things in yellow are bookmarks. So I can go from one bookmark right here. This one on the end here looks pretty busy. So let me go to this ACARS frequency. So this is Japanese ACAR. But again, they have Japanese aircraft landing here, I'm sure. So I just switched gears. Let me clear this out. This one's real busy. What's this one here? Yeah, so what I'm doing is I'm moving the cursor to handle that. That's actual voice. Okay, so you got voice at this frequency. So you got cockpit voice channels too, so you can listen to the. I'm not gonna play with the audio.
On the ACARS?
Not the ACARS, but this is another channel. So this is. See what I did is I'm looking at the signals now. I'm not reading the bookmarks. But if I go on the bookmarks, this one's a busy ACARS channel. So I click to the second channel. This is a worldwide ACARS. Now, see, you could see the bursts coming in. Actually, these are stronger than the US ACARS. Here comes the planes.
in their fleet status.
What the hell is that?
Modern engines have something called fully automated engine control. And it's basically, instead of having to sit there and watch turbine temperatures and all that when you're starting, you just hit a button.
Yeah,
And or if it's an internal, piston engine, it does all the fuel injection and mixture adjustment that idiots like me who don't have a lot of money do and manage the engine. And so FADEC is that, and lead status indicates the fact that it's a jet engine, because that's a function. There's high pressure that they tap off a jet engine.
now this message looks like it's typed, but other messages look like that's a telemetry message.
Right.
That one, this looks manually typed, but I don't know if there's a key of menu that flies out on ACARS, that transmits on ACARS. But this looks like a ad hoc message, that, hey, I got a problem with this. Hopefully it's not a fatal problem.
No, it doesn't.
You don't see many fatal problems. I haven't seen one yet, thank God. But anyhow, so this is the original ACARS. Well, what's interesting is this software, watch this. So if I go to this pull down menu here, see this box here, here's the frequency one. Now I changed frequencies because I went to another channel. That's 131.55. So that's 0. So 131.550, that's the international ACARS. That's why that's busier. You see the burst. There's a lot more burst coming through. One other thing, let me just show you real fast. This is kind of cool. So notice under the drop down menu next to DIG is digital protocols. Check this out. If I click on the drop down menu, when I first looked at this, I'm like, you got to be kidding. Now in all fairness, that the group that's updating and constantly working on this version of software there's this group. There's one guy in Germany that owned this software, and another group was supposed to fork it correctly, the Linux code, and they're wild card. So whenever somebody wants a protocol, or they think in Europe they want a different protocol, they'll add it to the list of interpreted, and write the code for it. So to give you some idea, this software, the version I'm running, has got, we mentioned ACARS. It also has ADSB, AIS. Anybody knows what AIS is? If you got a ship, Lee, you would know what AIS. So this is a ship reporting position.
Oh,
A 500, it used to be 500-ton vessel, but my friend's got a lightweight craft, and he's got ACARS on his. But it used to be for large tonnage of ships, but now, so this also read ships. So if
the Russians turn off when they're moving grain.
yeah, so right, exactly. So so look how easy it is. I could switch to AIS, but I also have to change the frequency profile to the AIS frequency. So I just left aircraft and I jumped over to ship. And needless to say, now ship is good for 30 to 50 miles tops. And that's open water. You're good for 30 to 50 miles. Now, okay, we got one message right away. So there's a North American coast station. He's monitoring the ships that's coming across. This is what you see here is mostly Delaware. Believe it or not, there's some ships that come up and down the Delaware into Bristol. I guess there's some large tonnage ships moving turbine blades, and they need ships to move it because it's too big for trucks. And so that's something if you want to see the activity. Now, as I go closer to the shore, because again, I'm limited to 30 to 50 miles, this thing lights up. So if you were on Chesapeake Bay right now, it would be completely flooding with messages of all the ships that it's seeing. And but we don't have any ships in Trenton or this area. But what I did is on the same band, if you look at this visual frequency, you have all these signals over here. So I can click on any of these, and these are NOAA. These are the NOAA weather. So if I wanted to know the latest weather, now this is narrowband FM, so I listen to it. I don't know if the audio is turned on here, but anyhow, you get the idea. So I can pick 7. There's 7 active weather frequencies that are continuing to be transmitted. Or I could jump back to ACARS 2, different frequency. You get my idea. So, but here's the stunning part. Watch this. So there's something called BPSK, binary phase shift keying number 31. What the heck is that? Well, that's a ham protocol. BPSK 63, so that's 63 symbols of binary phase shift keying. So if you're trying to demodulate binary phase shift keying, 31 to 30, this tends to be on HF bands. You got a code, this has been new added, so you got a code demodulator, so you can take a wide swath 200 hertz code and just have it interpreted on a window that pops up.
When you say code, Morse?
Yeah, so that's just regular Morse code. DSC, let's see what frequency that is. I haven't programmed anything for DSC. But that's a navigation. That's one of the navigation protocols.
$50 worth of hardware.
With, yeah, less than $50. Yeah, about $50. Oh. So ISM is interesting. Why? What did I am at? Let's pop into ISM, Bill, and change the frequency so we cover ISM. There we go. So why did I change the frequency? Because ISM is at 433. And I mean, if you guys want to pull me back to aircraft, we'll jump right back in here. But this is pretty cool. So what is this demodulating? What do you think this is demodulating here? These remote thermometer it's transmitting Oregon.
How do you know? How does it pull the header out and identify the
It looks at that frequency and it looks for the proper code to demodulate. It knows what the code is of Oregon and the different manufacturers. There's AccuRite Towers, another weather reporting, and I think that does something else here. So that'll be using humidity, the battery checks, flashes red when there's an emergency. So that's demodulating that. But here's something cool. If somebody's in the parking lot and they start cars, if you got a new car, it reports what cars started, Citroen or whatever. So if you're watching this, somebody starts their car, don't turn me in, but you know, there's actually reporting in the actual code it takes to open lock. Well, bad guys in Philly have figured this out and they can spoof this out.
Oh, there is.
You know. So anyhow, if you're on the dark side, plenty of opportunity, but I'd call the police on you. So anyhow, let's jump back to aircraft. Okay, so this is what's replacing ACARS, which is called VDL. That's your VHF link, data link, VDL, VHF data link. So did I clear that? So
none of this is encrypted.
No, nothing. Very little is encrypted with aircraft. I'm back to aircraft. They should be doing some more. Some of this may be encrypted. I've got examples of some encryption, but this is an interesting topic. What the hell's my time? You're supposed to be helping out.
What time are you supposed to get? It's 10:54 and you've got till 11:10.
Okay, cool. Okay, so this is what the government wants to replace ACARS with. In many systems, they both coexist. You know, aircraft sometimes you don't have anything on you have a light aircraft, right?
Right.
Yeah.
You don't have any of that.
So,
But it still says ACARS.
right. This is ACARS Gen 2, and they call it. They give it a different name though. It still is ACARS format, but it's enhanced. It scales better. You know, it takes up less bandwidth. I understand. So from a communications point of view, it can handle a lot more traffic.
So
God knows we need it.
It's deeper modulation.
Yes. Yeah. So I can give you by the way, this is an interesting book of this guy I've read all his, Philip Collier. He's a pilot. He's an international pilot, and he's written a book on intercepting. So he knows this technique and he uses a different software, but it's an interesting book if you get a chance. I think it's cheap. It's like $10 or whatever. But he's talking about, from a pilot's perspective, he talks about all these protocols, the latest, the original ACARS all through ADSB, which is one of the advanced. And then he talks about putting up a great antennas and low noise amplifiers. So he's a real serious guy that monitors. And okay, so let me just keep going real fast. I got about 10 minutes. All right, so this is the ACARS replacement, and they call it VDL2, version 2 of the this protocol. So let's jump to. All right, let me go down this list here. So here's a bunch of more amateur radio. Here's facsimile. So you can get wireless faxes. So if you're on a ship or you want to see a ship at sea that you can reach, you can click on fax and then see the facsimile of the weather is what they fax a lot on if you have a boat or an airplane. You want to get the fax on an airplane, you can use this. FST4, these are all amateur radio protocol. FT4, FT8, all written by one guy who was the leader, Joe Taylor. You guys know Joe Taylor. If you're a ham operator, you guys know him, right? So he writes this stuff. He writes it in the basis of improvements in signal to noise. So he has FST4. Again, these are all FT4, FT8. So FT4 is let's finish up with the aircraft ones. So
15 seconds.
Huh?
FT4.
Okay. Now here's an aircraft one. So when an aircraft is over the Indian Ocean, how does it communicate? Well, it might be using satellite. Not all the time. You can't trust the satellite. So a lot of times they have what's called, this is built in, which is high frequency data link. And this is using the ACARS format. It's on HF, so it covers a lot greater distance. And then there's a couple different formats on that. HF data link 2, that's an upgraded form of HF. And the next two are real kickers. HF global communications. Now this is what right now I'm kind of currently interested in this. This is the real deal. So this is using encryption. I don't know if we can get this. So this isn't even digital. So this is single sideband. So if I go to any of the, this looks like it's busy. Okay, so there's a series of these. It's not that many, but here's one in Honolulu. But now this is single sideband. So again, you should hear it. I don't think the audio's on, but they're not always transmitting. Now, why aren't they transmitting? What's the big deal about, why am I so intrigued by HF? What did I say? GCS. So this is a global HF that's some of my friends are very interested in, because why? That tells you when nuclear bombers take off. So whenever there's an incident in the world, this channel comes alive.
What's the range?
World. It covers the whole world.
So you think
Wait a minute,
they're
so-
watching from bomb or something?
Right. So here's the thing. This cannot be dependent on any network. Cannot be dependent on any satellite. What's left? HF. So the military uses this. So this is a military aircraft. And you can see where it's from, where the plane's taken off, but they have an encrypted message. The encrypted 40 byte message is what they display on it. And it's not displayed, it's not digital, but it's all verbal. So there's a voice on these channels that are reading off the message. So the message is, it's the only encryption that we know works, period. End of story, which is a one-time pad, equivalent of a one-time pad. So in a nuclear strike, this is the only thing, they're going to take out the satellites. Satellites are gone. All the communications is gone. This is it. This is the only Air Force has to communicate, regardless of, there cannot be a single point of failure in this period. So this is the Air Force HFGCS channel. So I haven't had much time to listen to this. And I think when I'm working late at night, I'm going to leave these channels on to hear. There are people that publish these messages, and they're not reading the messages. They're just telling you what the plane is. We took off from Dover Field.
How do you know where it took off? What is that in there?
It's in the header. Yeah, it's in the announcement.
In the what?
In the announcement. So that's in clear text.
That's not encrypted.
That's not encrypted. The message is always encrypted, but you don't know. There's a theory of just telling people. I've had 15 bombers take off from Dover Field.
Right.
And by the way, we're having an incident with Putin. You know, there's a threat of a nuclear war over our wonderful. Never mind, I won't get into that. But you get the idea. This is what's cool to me is this is a bomb-proof network, and it works. You know, and I've studied encryption, both from an academic point of view, and you do a history. I have a speech called "The History of Encryption," and basically one by one, even the money exchanges, the encrypted code they used, the original DES, that was cracked. Then they went to DES 2, DES 3. And they cracked all those easily. So you keep changing encryption. That's why I have no faith of cryptocurrency. Now that's just personal opinion. They say it's uncrackable code. Ha ha ha. Yeah. Anyhow, so this is cool. Keep your eyes on this one.
So the encryption here is digital, or with it using a
one-time pad. So there's a voice comes on. It says 4 8 0 P and sideband, single sideband.
Mm-hmm.
And a voice appears, and you know the plane, but they make the announcement on the plane and the airfield, but you don't know the messages.
And that's the pad code.
Yeah, it's a one-time pad they use. How you maintain that is like a nightmare, because you can't, if you exchange something over the air, it's not robust.
It's flying old Enigma machines. So.
Well, Enigma, they cracked Enigma.
Yeah, I know.
Multiple times. Okay, so JSA call, that's one of the digital communications one of the newer ones, which is kind of interesting because it's long distance, high signal to noise, low power, and you can communicate entire messages. It's not, you can type like you're sending a text message to somebody.
What's the frequencies for that?
Okay, well, if I select this, I could select this definition. So it's talking to the RTL SDR. That's the version 3 SDR, and I'm going to use. And
who uses this?
Let me see. I don't know if did I put this in? Okay, I didn't put this in. So you can find it at 10 meters. So if I go up to my 10-meter window, and this is what's going on in 10 meters right now. There's slow scan TV. Look at the upper bookmarks. And here's Whisper, here's FT4, here's JSA call. So let's see if that's active right now. You can adjust the waterfall.
What's Whisper?
Whisper is the original Joe Taylor protocol that can go. I've seen experiments with Whispers that go like 200,000 kilometers with 0.001 watts of energy transmission.
A lot of error corrections.
What's that?
A lot of error corrections.
Well, it's working a very narrow bandwidth. It works on 6 hertz, 6 hertz signal. It shifts 6 hertz. And it works off of, anybody knows Shannon's law. You go narrow bandwidth. The other side of that is the Johnson noise. So you're up against thermal noise, But you take the bandwidth and drop it, Now you got a stability problem because if your receiver is not stable, you're not going to see your 6 hertz shift, you know. So this is 10 and 11. 11 meters is citizens band. So you wanted to listen to any of the citizens band chatter is over here. But I keyed up on JS8 call, but I don't see anything active on that. Next to that is
What's it used for?
oh, just texting. So I want to use a ham radio protocol to just send a longer text rather than, hey, I'm W2JEJ. That's FT8. A lot of people like FT8. Here's FT8, FT4. You can see how terse. So if I click on FT4, this is what you're going to get. Let me clear out the window here. So you open a window here, and you see all those squiggly lines are in FT8 signal. There it is. So it's coming through here. Okay, so that's give you a quick idea on what FT4. This is FT4.
We have about 4 to 5 minutes.
Okay, we covered this HFDL, so that's your high frequency digital. So, but this is cool because you're seeing this in real time too. And by the way, if you want to know what the planes are, if you look next to this, say here's an aircraft. I can click, these are all linked. So now I'm going to click on aircraft. Watch this. So then it goes into flight aware. Lee, did you see this? Yes, it jumps in flight aware. And it says that this is the flight. It's from JFK to Japan, ODA Japan. And here's the flight in real time. Now this is from the internet. This is called flight aware. So we're seeing the signal in real time RF from the airplane. This is off the internet, so it's a collection of, and then look at the data it interprets. So it's interpreting not only the flight and details, but it gives you a timeline of the velocity versus altitude. So it just took off. You see the velocity.
And this data is coming off.
This is coming off the internet.
Yeah, I know that, but I mean,
Cool.
the data from the plane is coming off.
Flight aware.
Yeah, but I mean, no, but I mean, the plane is transmitting.
But the plane itself, if you want to see, is transmitting all this. Yeah.
The
But-
plane is transmitting by not ACARS.
No, but it's giving me the ACARS is the basics right from the airplane. So this is what I've linked on between here and there. See what I mean? I just clicked on this aircraft.
Okay.
This is the timestamp of when it came in. And it's a American Airlines flight 167. And when you want to see more, you go here, and this is the detail, the flight details. And so if you really want to track a flight, this is cool.
Including Elon Musk's private jet.
Well, I don't know if he turns the transponder on. You can.
There have been some seats.
Presidential flights, Air Force One now is fully encrypted, and they turn off location. Well, especially when they fly international flights, they don't want to know, another country where you're landing.
Do you know that there are 2 analog backup Air Force Ones,
No, I didn't know that. That's cool.
just in case all this digital stuff? And after what you just said,
Yeah.
I'm really scared.
Well, like I say, there's a whole dissertations done on lack of security with this, because now if I can see it, I can spoof it. Could I generate these? Oh yeah, I can generate it right from my house. And if I get the strong enough signal, Al gave me a 400 watt amplifier. I put the transmitter on a 400 watt amplifier. I'll do work. First of all, you can take out GPS. That's no problem. Or GNNS, they call it now, because they don't like Air Force ties to GPS. Anyhow. But it's, but you're right. I didn't know that. That's you probably want a digital or a real twin for security. What about presidents that aren't presidents that are somebody doubles, body doubles? Do you believe in body doubles?
Anything's possible.
Al always told me, don't go there.
Thank you, AI.
Okay, so, okay, are we done with these protocols? So these are all the aircraft protocols that you can get. And again, JT65 is an amateur radio. It's one of the oldest. And this is something that Al used every day in his EME work. This JT65, you like that a lot. And RIDI is the old fashioned. Slow scan TV, Cytor B, that's a protocol. We talked about VDL2 as the replacement for ACARS. Whisper is they call it Whisper. It's very low noise, very effective data transmission. And I worked with students here on their tracking their balloon using Whisper. Now you have to get a license for that, so that's extra credit. Students have to get a federal license. There's more to learn, you know. And this is a protocol I have no idea. It's the only protocol here I have no idea. ZVEL. I know it's a European German protocol. Anyhow, so this is. Should we wrap it up now? If you got any questions, you can always get a hold of me. If you want to copy the deck, I'd be happy to give it to you.